Recording in progress.
So today we'll be looking into your experiment 10, that is disk scheduling algorithm. Okay, so first we look into what is a disk structure, its components, and the two algorithms that are used. So in your disk structure, you have your disk drive. Okay, as what happens here is in your disk drive, it is addressed as large one-dimensional arrays of logical blocks, where the logical block is the smallest unit of transfer. And here you have your track, your sector, and your cylinder. Okay, these three are the main concepts here. Okay, and here this one-dimensional array of logical blocks is mapped into the sectors of the disk sequentially. And then this sector 0 is the first sector of the first track on the outermost cylinder. Okay. And this is mapped in an order where it proceeds through the track, then the rest of the tracks in that cylinder, and then through the rest of the cylinders from outermost to innermost. Okay. So the pattern which it follows is from outermost to the innermost. So this is the common disk structure. And the main part here is your disk structure has, okay, it has a cylinder, okay, as you can see, this part, okay, this complete part is considered to be a cylinder, okay, whereas in a cylinder has different tracks, okay, as in here you have, this is one track, this is another track, and this is another track, okay. A cylinder has different tracks, and each track has different sectors. Okay, so as you can see different partitions here, each one is considered to be a sector. Okay, here too you can see that each partition is considered to be a sector. Okay, and these are the main components in your disk. Okay, your disk structure. Okay, the main components in your disk structure is your cylinder, sector, and your track. Okay, and these are supported by a plater. Okay, this is the plater, and then it is also supported by a spindle. Okay, and it also has an arm assembly and an arm. Okay, this spindle helps in its rotation, and this arm assembly, the arm and the plater, okay, all these help them in supporting the disk structure. Okay, as in the cylinder, sector, and track are placed on the plater. They are placed on the plater and they are supported by the arm assembly and the arm. Okay, so this is your disk structure. So coming to disk scheduling. So here, the scheduling is done by your OS to schedule your input and output requests which are arriving for the disk. And the operating system is responsible for using hardware efficiently for the disk drive, which means it only means that you're supposed to have a fast access time and a fast access for the disk bandwidth. Okay, and this disk scheduling has four major components. Okay, the first one is your seek time. The second one is your rotational latency, and your third one is transfer time, and your fourth one is disk access time. Okay, so all these four components, okay, their main purpose here is to minimize seek time. Okay, so you might wonder why are you learning related to your disk structure, disk scheduling, and you're also going to look into two algorithms. Okay, first come first serve and shortest time. So these two algorithms, what is the purpose here is that the goal here is to minimize the seek time. So for that purpose, we'll be looking into all these four terms and the other two algorithms where we'll be implementing these. So seek time, okay? So seek time is the time taken to locate the disk arm to a specified track where the data is to be read or it can also be written. So the disk scheduling algorithm that gives minimum average seek time is better. And rotational latency is the time taken by the desired sector of disk to rotate into a position so that it can access the read or write hits. So the disk scheduling algorithm that gives minimum rotational latency is considered to be better. And coming to your transfer time is the time where the data is transferred. Okay? And it depends on the rotating speed of the disk and number of bytes to be transferred. And so how do you find for what happens in disk access time is you're just going to add up all the seek time, rotational latency, and your transfer time, which would give you your disk access time. So we'll be looking into algorithms, the two algorithms, first come, first serve, and your shortest seek time. Okay. So in your FCFS, okay. So what happens here is in FCFS, the requests are addressed in the order they arrive in the disk queue, okay, which is first come, first serve. So several algorithms exist to schedule the servicing of disk input and output requests. So what you're going to first do, so it is mentioned here, we illustrate them with the request queue from 0 to 199. It means that you're going to draw a graph from 0 to, okay, 199. So now you're going to just look into your queue and also your head pointer. Okay, so which is the smallest one? It's 14. I'm going to just draw the graph, okay, normal graph. 0, 14, then 37. And I can put in the head pointer of 53, then 65, then 67. Then I guess it's 98, and then 122, 124, and then I think 183. Okay, I mean, this would all come here. Okay, so and now what are you going to do is you're going to take up your head pointer. Okay, head pointer minus the first cube, that is 53 minus 98. Okay. Okay, after this, what happens is now 98 becomes the head pointer. Now 98 minus the next one, that is 183. Okay, now after this process, 183 becomes the head pointer. That is 183 minus 37. And then 37 becomes the head pointer. So you're going to follow this. Okay, you're going to minus and then finally you're going to summarize and you're going to find the answer. So this is how the first come first serve works. Okay, so you can see the illustration here, right? 0 to 199, right? 199, and you have your queue here and your head starts here, and it has all been calculated, and then you summarize it by you add it up, and then you find the total seek time, that is, it is given as 640 cylinders. Okay, so this is your first come first serve. So what happens here in this algorithm is you have a request array. These request array represents an array storing indexes of tracks that have been requested in ascending order of their time of arrival, where head is the position of diskette, and one by one the tracks are taken in default order and they used to calculate the absolute distance of the track from the head, and then they are incremented for the total seek count with the distance. And then the currently serviced track position now becomes the new head position. And then you go back all over to step 2 until all tracks in request array which have not been serviced. So this is your FCFS, and this is the sample output that has been given. The number of tracks, the queue, the head start, and the differences are mentioned here, and the total counted, calculated total head units. So now coming to shortest seek time. Okay. So as of now, we've seen the first algorithm, first come, first serve, and now we'll be going to the second one. Okay. So here what happens is the seek time of every request is calculated in advance in the queue, and then they are scheduled according to their calculated seek time. So selecting the request with the minimum seek time from the current head position, and then this scheduling algorithm is also a form of shortest job first scheduling, which may also end up in starvation of some requests. So we have another example. So here you have your illustration the same from 0 to 199. So what happens here is you are going to, since it is the shortest seek time, you'll be taking up 53, okay, which is your head start is 53. Minus, you're trying to find out which is closer, that is the shortest seek time. So 53 is nearby to 65. So I'm going to go for 53 minus 65. And then now the head starter is 65 now. Okay. So 65 minus what am I close enough to? 67. and then 67. Now the head starter is 67 minus 67 is nearer. That is the seek time is lower with 37. So 37, now the head starter is 37. 37 goes to 14 minus 14 plus now 14 minus it comes up to 98. Okay, and then it goes on like that 98 to 120 to 120, 124 from 124 to 183, and all the queues have been covered, and then your total seek time is calculated. That is what happens here is the same, that is the request array represents an array storing indexes of tracks that have been requested where head is the position of diskette, and we also find the positive distance of all tracks in the request array from head, and to find a track from requested array which has not been accessed or serviced yet and has minimum distance from head, and it also helps to increment the total seek count with this distance. And the currently serviced track position now becomes the new head position, and you go back all over to step 2 until all the tracks in request array which have not been serviced. So it's your given sample output 8, the queue, the head start, and then the head differences differs, right? And then your total head moment given here is 236. So as of now, you've seen your disk structure. Your disk structure has your three main components, right? Your track, your cylinder, your sector. Okay, and then you saw about this scheduling. Your scheduling, it had 4 components. Okay, it had 4 main components which are used to minimize the seek time. Okay, your goal here is to minimize the seek time. And you also saw 2 algorithms, first come, first serve, and your shortest seek time. Okay.